I'm 8 years old and I love science. That was me roughly a decade ago. I'm a mechanical engineering major now, and I still have that same childlike wonder of joy when I think about the magic of science. A lot of that was created by places like the Great Lakes Science Center, which is a museum with tons of interactive science exhibits. When we saw the MakeOHIO Tech for Change Challenge, my mind immediately went to an ecological problem I've lived near my entire life: the toxic algal blooms of Lake Erie. We realized that traditional textbooks and standard teaching methods don't connect with elementary age kids, so we needed to reinvent how kids learn about ecology. So we created Algae Bloom Simulator. This is our minimum viable product. We used an ESP32 kit to build a physical, interactive model of a lake ecosystem. Behind the scenes, we engineered a multiplicative algorithm between two variables: an algae growth knob using a potentiometer and a light level detector using a photoresistor. In nature, you need both nutrients and heat for an algae bloom. As you can see, if the algae knob is at 0, but shining a flashlight on the sensor does nothing to the risk level. As you can see, it is 0. The lake is safe. If we turn the algae level all the way to the right, which would be 100%, but we cover the light sensor, the risk level is still at 0 and the water is still blue. But the real magic happens when they interact. When a user combines high farm runoff with intense summer sunlight, pushing the risk level over 60%, the risk level is now at 100%. The water turns green. At any point over 60%, the alarm will beep, the water will turn various colors of green depending on the risk level, and this turns an invisible chemical crisis and makes it instantly observable. We didn't just assume our product would work, we tested it. We brought a user who knew nothing about our project. We gave them a brief 15-second little description, which is roughly the equivalent of reading a museum text placard. And then we timed him. He actively interacted with our device, testing different combinations for 4 solid minutes. In the museum exhibit industry, a 4-minute interaction time is incredibly high. This proved that our product and this tactile approach would stand the test of time. Beyond education, this product is highly cost effective. This MVP was built using around $30 worth of components housed in recycled cardboard and upcycled materials. But is a full-sized final market value product actually feasible? Yes, it is. We consulted with Derek Van Allen, a mentor at MakeOHIO and a material science engineer at Boss Display, a company that professionally manufactures interactive museum exhibits. He validated our technical approach and confirmed that scaling this to a commercial museum exhibit is a highly feasible and backed by market reality. Looking forward, we plan to apply for a design patent, and we also want to add prevention features where children can push a button to plant trees to block the runoff and save the lake. We aren't just building a Makeathon project, we are handling the spark that will inspire the next generation of 8-year-old scientists to protect our Great Lakes. Thank you.